Hey guys, Daniel Bock here from JumpScience.com. This is the fifth and final video in the series on muscle tension. This one is covering the myotatic stretch reflex. Alright, so first thing to understand is you have a wide variety of sensory receptors all throughout your body that give you information about what's going on. Alright, now one of those types of receptors is called the muscle spindle. Alright, so let's say we're looking at a muscle and we've got contractile muscle fibers in the muscle, right? But also we have in there a different type of fiber that's actually not even designed for producing tension, but it's actually a sensory fiber. Okay, these are your muscle spindle fibers. So there's a couple different types, but basically what they do is they detect changes in length of the muscle. Alright? And then they've got sensory neurons that are connected to them that send the signals to the central nervous system. Okay? So, your muscle spindle fibers all over your body are constantly sending information about the length of your muscles. Alright? That's going on 24/7. However, the particular mechanism we're going to talk about today is the stretch reflex. Alright? And that's going to happen when we get fast lengthening of the muscle. Okay, so let's say that this muscle is lengthening fast. Now that's a dangerous situation for a muscle, right? If you lengthen too fast, too far, something could get damaged. So what's going to happen is as that lengthening starts to occur, the muscle spindle fibers are going to sense it. They're going to start sending signals through this sensory neuron. Okay, those signals actually don't even have to go up to the brain. There's going to be an automatic response in the spinal cord to send signals through your motor neurons, okay, to your contractile muscle fibers to produce more tension. All right, by producing more tension, they're trying to stop that lengthening to protect the muscle. All right, that is the stretch reflex. Fast lengthening stimulates more contraction, all right, to protect the muscle. It's a protective reflex. However, the stretch reflex also serves the purpose of adding force to a lot of our athletic movements. Okay? So let's say that we are loading up for a jump, right? When you load up for a jump, you're going to have this fast forward translation of the knees and shins, so your ankle is going to be going into fast dorsiflexion. That means your uniarticulate calf muscle, your soleus, is going to be lengthening quickly, right? So, muscle spindle fibers sense that, signal goes to the spinal cord, signal comes back through motor neurons to stimulate more contraction in the soleus. You add force to that contraction, you add force to your ankle extension, you add force to your jump. Right? Same thing going on in the quads. Because your knees are bending as you load up, you have fast quad lengthening detected by the spindle fibers, goes up to the spinal cord, comes back and stimulates more quad tension, more forceful knee extension, and a more forceful jump. Okay, now the same thing is going on when you strike the ground in a sprint, when you cut, when you load up to throw, right? The stretch reflex enhances a lot of our athletic movements.